Welcome. In this video, I'm going to be discussing on aromatic compound, as you can see on the board, on aromatic compounds. In my last video, which I titled Appetizer to Aromatic Compounds, you can go on my YouTube channel, search for it and watch it before coming over to this one. But let me start like this. And I want to actually give you a nice introduction and understanding about aromatic compounds. Whenever you want to define an aromatic compound, these three keywords must be involved. An aromatic compound is a cyclic, conjugated organic compound. Cyclic, they are in a ring form. Conjugated is a phenomenon that explains the fact that in their arrangement, there is single bond and there is double bond. And what is the arrangement of this single and double bond? It is alternating. One single, one double. One single, one double. But they are not in a straight form like our alkane. They are in a cyclic form. Something like this, like our benzene ring. The most common of them is benzene. Double, single, double, single, double, single. So whenever you have alternating double and single bond, you call it conjugation. So when you want to define an aromatic compound, you define them as a cyclic conjugated. The first known aromatic compound is benzene. Benzene, which has this molecular formula of C6H6. How can 6 hydrogen satisfy 6 carbon? In each of the carbon need 4 bonds. Of course, it won't be enough. That's why the concept of conjugation comes in. Putting at interval a double bond. Now, this is the propanded structure for benzene as given by Kekulé. Double bond, leave a space, double bond, a space, double bond. You see that there's double bond, there's a space, double bond, single bond, double bond, single bond, double bond, single bond. That's what we call alternation. But one thing that we have to understand under aromatic compounds is that the way I give you this structure, I give this structure, seems as if this double bond is in that fixed position. But one concept we understand in aromatic compounds is that their double bond is not in a fixed position. It moves about in a ring form. So it's here before, it is shifting. This one is here before, it is shift more further. This one is here before, it is shift more further. These are the two structures provided by Kekulé, a scientist. When he was trying to explain the structure of benzene, giving us these two structures, is telling us that the double bond is not in a fixed position. But even at that, we want a structure that even the only structure, that one structure, can tell us all about benzene. And to date, actually, there's no actual structure that can tell us what an aromatic compound is. Example, benzene. So I can be saying benzene, I can be saying aromatic compounds. Benzene is the first recognized aromatic compounds. So benzene is a representative of aromatic compounds. Now, the scientists now agree to rather be using an hexagon with a ring inside. This ring is representing 3 double bonds at interval between the carbon of these aromatic compounds. And these two structures are two structures that explain the delocalization of pi bonds in an aromatic compounds. And delocalization means these pi bonds are not in a fixed position. They move about. I hope you understand. Now, in the next video, I'm going to be taking you through some more details about benzene structure, the reaction they undergoes, and some more things you have to know. But just know that aromatic compounds is a cyclic, conjugated organic compounds that possess special stability due to their ring structure and because of their conjugation. Conjugation of pi bonds. Pi bonds that give pi electrons that are delocalized, they now move about in a ring, giving them a special stability.